BCD is it's easy once you know what it is.
Yes, it is. And so BCD can have gray code too, like the name of BCD can be a gray code.
Well, it's a code, like they're not the same, but it's a code. Okay, I understand. It's like ASCII. ASCII is a code. Binary coded decimal is a code. Gray code is a code. They're all different because they're representing different things, right? I understand that.
All right, gotcha.
So BCD directly represents numbers, right? ASCII code, you have numbers and letters, right? And symbols, basic symbols.
Right.
Gray code is a high speed, it's numbers, but it's a high speed counting code. None of the codes are weighted. They are not numbering systems. They are codes, right? You understand? And I think I showed y'all Unicode, which is used primarily now. You got your worksheet on this?
So pretty much anything that's like coded.
Anything that's not a number has got to be represented with a code.
But it all goes back to binaries.
Yeah, it's all ones and zeros, but the only thing the computer understands is ones and zeros. It's just that we got to do something with ones and zeros besides numbers. So when I look at the keyboard, there's more than ones. So if this was true binary, then I'd only have two keys on my keyboard, and what would they be? 1 and 0. But yes, I see an A key on my keyboard. Well, that's not a number. That's the letter what? A. But I got to represent it in ones and zeros. So there's a code. It's called a key scan code. So these computers don't use ASCII. They use the key scan code. But it's still a code. So every time I press this button, an A don't go into the application that's running the program at the time. The code for an A goes.
So like if somebody's hacking something, they're just hacking the code. They're not actually hacking the binary. They're hacking the code to get.
Well, it all depends what level you're getting into.
But essentially, they're just breaking the code down to get to the binary itself, right? Or the pattern.
The pattern. So when I tell the microprocessor something to do, we call it an operational code or opcode, and it's a binary code that tells the processor to add, or subtract, or multiply, or do this, or move data, or do that. It's a code, right? You understand? So your computer's got to deal with a lot of other stuff, but besides what? Numbers. So if it's not a number, it's represented with a what? With a code of ones and zeros. And of course, the ASCII code chart that I gave y'all, the ASCII code is a binary code, but the chart is set up in ASCII. Hex, just because it's easy, right? So anything I do on my computer that's not a number, it's got to be represented somehow with a code. So I'm still waiting, guys. You want to work any of these?
The 1395 on decimal 1, 2, 3, 4, 5 slots.
1, 2, 3, 4, 5. This guy.
Yes. I don't know what's my error.
Well, first of all, we're going from BCD, right?
Mm-hmm.
1, 3, 9, 6.
I thought it was a 5 at the end.
It is a 5.
It's a 5. I'm trying to get the octave and the hex right.
Octal.
Octal.
So 1, 2, 3, 4, 5. 1, 3, 9, 5.
Yes, I know how to get that.
Okay, I got it, right. I just think
So 1. 395. Okay, so this is BCD. What's nice about BCD, you can go directly from BCD to decimal by just writing down the code that, so this would be 1395
This the only thing I like.
base 10. Okay.
Yeah.
So what we can do now is we can go to base 2. So I'm going to start with a chart. 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, and 2048. So I know I've got it up there. And I say, okay, what's the biggest thing I can subtract from 1,395? What's the biggest thing?
2,048.
I can't subtract 2,048. Okay, remember, you're not subtracting this number from that number, you're subtracting this from that.
That's correct.
What I do is I always go one pass on my chart to make sure I've got enough up there. So I'm gonna go 0, 1, 2, 4. I'm gonna subtract that from this. What do we get?
Three,
371. Okay, this is still base 10. Can I subtract the 512? Yes or no? No. Can I subtract the 256?
Yeah.
How many times? It's gonna be 1, right? I understand that. So minus 256, so subtract that. What does that give us? What's that?
150.
We okay? Okay, can I subtract the 128?
No.
No.
0.
Can I subtract the 64?
Yeah.
Okay, so I'm gonna subtract the 64. What does that leave me? 51. Can I subtract the 32?
Yes.
Put a 1 up there, subtract 32. What does that leave me? Can I subtract the 16?
Yeah.
Okay.
3.
Can I subtract an 8? No. Can I subtract a 4?
No.
Can I subtract a 2?
Yes.
And a 1. Okay, I started off with an odd number. I ended up with an odd binary number because I've got a 1 in at least this bit, so at least it's got a chance of it. Right. Okay, so this gives me my binary. So what I can do now, for octal, what I'm going to do is I'm going to split it up in groups of 3s. 1, 2, 3, 1, 2, 3, 1, 2, 3. Right? So my octal is going to be 2, 5, 6, 3. This is base 8. Okay? Okay? We just take these numbers right here and convert them into 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay. So this, if I look at this by itself, this would be a 1 and a 2. What would that be? 2. This would be a 1, 2, 4. That would be a what? 5. This would be a 1, 2, 4. That would be a 6. This would be a 1, 2, 4. This will be a 3. So now we're not dealing with 1, 2, 4, 8, 16, 32, 64. And we'll do the same thing with hexadecimal. But it'll go 1, 2, 4, 8, right? I understand.
These videos are accessible on Blackboard, right?
Mm-hmm. Well, not on Blackboard. They're available on YouTube. So what I'm going to do here now is I'm going to split this into groups of 4s. One, let me erase that thing up on the top before I get confused. And now I'm going to split them into groups of 3. Groups of 4. 1, 2, 3, 4. 1, 2, 3, 4. So it's gonna be a 5, this is gonna be a 7, and this is gonna be a 3. This is base 8, this will be base 16. And that's all of them. So what heads, we use groups of 4s, right? Octal, we use groups of 3s. In BCD, we just go directly from it, right? You understand that?
Alright.
Any more? So what do we do first? I can't go directly from BCD to binary. They're not the same. BCD is a code, but somebody's going to do that on the test, and I don't know what to do about it. They're going to go, I'm going to say go from decimal to binary, and somebody's going to go from decimal to BCD, and they're going to give you the BCD answer. And this is basically what part 1 of the test looks like. Just same thing you got right there.
Okay.
It looks the same. It's different numbers. Any more?
Well, you ain't got to put a 0 in front of that, maybe.
Yeah, and this is what I explained. I can come all day long and I can have the number 6. You can stick as many zeros on the left as you want to if you need to get it in a group of 4. Now, I can't stick a number on the right to get it in a group of 4 because that changes the way. So yeah, if you want to do that, you're more than welcome to stick that 0 right there. It's just I've been doing it so long, I see the zeros out there. So just don't stick a 0 there. No, don't start on the left and work toward the right. Because I've seen people do that. They'll come up here. This is wrong, by the way. So y'all do this. I've actually seen people do that. They'll come up here and start what?
Adding 0.
Yeah, no, it's just convenient. They'll just come over here and start saying 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, and they stuck a 0 right there. Well, what you did is now I'm up to 2048, right? You understand it's not the right number. So you always start with your least significant digit and work towards your left, right? So let me get that off because I don't want people to do that. More questions? It's good. It's wonderful.